we like to say water always wins. So,
having grown up on the Gulf Coast, I can vouch for that.
Exactly.
This episode of the Fabricator Podcast is sponsored by Schuler North America, a subsidiary of Schuler Group. Schuler North America, headquartered in Canton, Michigan, provides new equipment, spare parts, and a portfolio of lifecycle services for all press systems. Schuler's hydroforming division provides localized tubular hydroforming production, die design and development, parts prototyping, and full turnkey hydroforming solutions such as design, feasibility, and tryout support.
This is Dan Davis of the Fabricator Magazine. Welcome to this very special episode of the Fabricator Podcast. Today, we're going to get a little bit more into technology than we usually do. So joining me today is Chris McMahon of Schuler North America. Thanks, Chris. We're going to talk about tubular hydroforming, and I think if you don't know what it is, you're going to want to stick around and learn because it's kind of a cool technology. But first, Chris, what's your background? How did you get involved with this?
My background is metal forming, stamping, wireframe assembly. So just new to Schuler, almost a year now. Previous to that was with the metal stamper, wireforming in the seating industry. Previous to that was with an extruder, plastics, roll forming. So I got a broad brush of industry experience and metal forming, a little bit of plastics, but we won't talk about that on this podcast for sure.
Thank you. There you go.
Yes, but that's my background, automotive primarily.
And what exactly is tubular hydroforming?
Tubular hydroforming is we're a smaller part of Schuler North America. So Schuler, a lot of folks should know Schuler. If you don't, check us out. But tubular hydroforming is we load a tube into a die, and you close the die and you fill it with water.
Yeah.
So we focus on, there's various forms of hydroforming. There's sheet hydroforming, and basically using fluid, hydraulics, to form the part. But tubular hydroforming is you load the tube into a die, you close the die, and you use water pressure to make the form.
Okay.
That's in its simplest form is what it is.
So we actually had a hydroforming journal. We published probably in the late 90s, early 2000s. So it's been around for a while. Why should someone choose Schuler for their hydroforming needs?
Really, for why Schuler, it's the technology and the team. So obviously Schuler and part of Schuler, we have the largest OEM local OEM support network in North America, based in Canton, Michigan. So we're just outside of Detroit. But why Schuler is the technology and the team. Each person on our team, except for myself, has at least 10 years of experience with hydroforming in one shape or form. But why Schuler? It's the, like I said, technology and team, but we have the production in Canton, Michigan, so we're a bit unique. We have production. We make over 1 million parts per year in Canton. We serve as a tier 1 in some cases, but typically a tier 2 or tier 3 supplier. Hydroforming is a bit of a niche. It got a bad rap. I don't want to be negative. Many years ago, a lot of your oven handles and things like that were hydroformed, a lot of expansion on the ends, stainless steel that had a lot of annealing and some dry lubricants, and just hydroforming. People think hydroforming is expensive, and what we do, we just use water with a little bit of lubricant, but it's 95% water. So we put a part in, for example, we make a lot of trailer hitches for the OEMs, and we load a tube, we press bend it, hydroform it, shape it, pierce it, and put it in the customer's container for the next assembly process for welding. So that's why Schuler, because we can you're not bending it, annealing it, hydroforming it, annealing it, cutting it. So that's what we focus on. It's a very simple step. We do post-secondary operations as well. We can do laser cutting and finishing, welding, but really we focus on just hydroforming, making the part and shipping it out.
The motivation for customers to come, is it mostly related to elimination of secondary processes, cost-effective part development?
Both. You can, for example, we made a rollover protection system for an off-highway industrial customer, and they had 5 or 7 different parts and stampings to make cab sides, again, for a wheel loader to protect the occupant. And working with them over a couple years, we make one hydroformed tube. It's a very 6-inch diameter hydroform tube, and it basically gave them one part or two parts, a right and a left, and gave them repeatability. So it took out a lot of additional steps in welding and processing.
Right.
And what they found is with their previous process, beyond the cost, cab to cab, they weren't getting the same part. So with hydroforming, it's very consistent part to part. And tubular hydroforming, you got to think as there's a die, but it's almost more like a mold.
Gotcha.
So you're loading the tube in, you're sealing it, you're forming it. So it's very, very consistent.
Yeah. Is there material thickness, wall thickness that comes into play?
Absolutely. And again, every part is different.
Right.
But we typical parts are the 2 to 3 mil wall thickness, but we do have a part that's 16 millimeters thick.
Oh, wow.
So we hydroform, we press bend and hydroform a 16 millimeter thick part. So there's limitations, but again, the part size, shape, and the end product dictates that. So we like to say water always wins. So
having grown up on the Gulf Coast, I can vouch for that.
Exactly.
Can you the trailer hitch thing is very interesting in the sense that I always thought that was kind of a solid product, like machined, but yet you kind of described it as a kind of a result of the hydroforming process.
Yes.
Is there much success in taking parts that were once done in a traditional manner and maybe adapting it to hydroforming?
Absolutely. A lot of your trailer hitches, certainly in your aftermarket, are CNC rotary bent, and that's fine.
Yeah.
But you have variability. I mean, there's material variability. Tube to tube, we use welded tubes. They're rolled and welded, so not every part is perfect. But hydroforming, we basically, we lock it down and force it into submission, for lack of a better term. So again, that mold aspect, you get part to part, is a lot more consistent. We also do some axle. The 16 millimeter part I was telling you about is an axle for a heavy truck.
Right.
So again, it's very consistent, and you're locking it in.
Yeah.
Where CNC rotary bending, as it can be done, may not be as consistent if you have any material variability. Hydroforming is obviously, we feel, a lot better for those processes.
I see. And we've talked about some examples. Do you have other success stories that may be connected to the hydroforming process?
We do, and part of getting back to why Schuler, great success story for us is we have a customer that has Schuler presses. They do their own hydroforming. They do their own stamping. We worked with them, and in this case, it was Ford Motor Company, to develop the tools and the hydroforming. Schuler did a lot of work back with the aluminum F-150, and I'm not speaking out of school. It was in the news, and helped Ford develop a standard for hydroforming. And but a recent success story is working with our customer. They had Schuler press. We worked with them on the tooling, and they were the tier 1 to Ford, and Ford extended a part on the new Mustang, and they didn't have capacity. So they're able to come to us and say, Schuler, we need you to take this one part back that we've been running for the last 2 or 3 years. We need you to take that back because we don't have capacity, and we were able to do that. We made an investment on our part in a bend cell, so we had to invest in a bend cell. But that's a real success story, is being able to help our customer, ultimately the OEM, maintain production when, as we all know, things happen. This gets extended and there's not capacity at our place. We can plug and play that. So that's another thing about Schuler being in Canton, close to the Detroit 3. We're able to just plug and play and assist our customers. We can also, if there's a press down situation, God forbid that happens, but it does happen, we can plug those tools into our process, and away we go.
Do you feel like the education level of people in industry are where it needs to be to understand what hydroforming can do for them?
Personally, no. Because again, like I said before, hydroforming in some ways got a bad rap years ago. It's like, well, that's expensive, and you've got to do this annealing and this dry lubricant. And then those processes are fine, but we've simplified it. I feel we've simplified the process. So that's why we want to educate the market and the industry that what we can do with hydroforming. It's evolved. Like I said, it used to be a lot of oven handles, a lot of expansion, little T fittings for plumbing, obviously PVC, plastics, unfortunately, for our metal formers have taken that over. But hydroforming's evolved into the trailer hitches, roof rails. We do a lot with dual phase materials, so we hydroform any metal, but dual phase materials a lot for rollover protection in various cars and trucks, and aluminum, as I mentioned with Ford back in the mid 2000s for the F-150.
Schuler can not only do the hydroforming, they can sell the presses that do the hydroforming, but they also help engineer systems for people that may be interested in hydroforming.
Absolutely.
Is that correct?
Absolutely.
How does that work?
So we have a team, like I said, a great team with 10 to 35 years experience. If you add up everybody on the team, there's well over 150 years experience in total. But we work through the FEA analysis, the simulation. So we have the simulation software to help customers understand how a part can be hydroformed, and we help them design the part or input to it. Obviously, the customer, most cases, is design responsible, but we have a team who will do the FEA. We can do the prototyping. We can do, obviously, the tool build, and as we've already discussed, the production. But we do have customers, and they may not be a Schuler Press customer, that we sell tools to, and we offer the support. As I said, having the largest local North America OEM support network for presses as well as hydroforming.
Right.
So we have many customers that don't have a Schuler press yet, unfortunately. We'll work on that. So yeah, it's working directly with the customers' engineers. We do get parts, hey, we want to hydroform it. We mentioned before CNC rotary bent, some axle parts. Like we're getting some inconsistency part to part, so we can work with them, show them where the thinning areas are, and help them evolve that design into something that can be hydroformed and put into their vehicle and their product.
Yeah. Is there a good volume level for hydroforming?
There is, absolutely. I mean, the trailer hitches we run for, one of the Detroit 3 is well over 300,000.
Okay.
Right. I mean, obviously, tooling investment is a consideration. I will say a hydroform tool is a bit more than your typical stamping tool.
Okay.
I mean, it's not going to be 100 to 150,000. It's going to be a bit more than that typically. But the volumes we have, the axle tube, I told you, we run about 500 a year.
Okay. Wow.
However, that application, the CNC rotary bending wasn't acceptable. So, and then we have parts we run, over 300, 400,000 a year. So it just depends on the application. The rollover protection for the off-highway projects is about 10,000 a year.
Okay.
So again, as with any project, your capital tooling investment, how is it amortized? But automotive has a little bit shorter window to look at. They're usually looking at 5 to 7, but your off-highway folks are looking at 10 plus years.
Okay.
So that's another thing to consider when hydroforming. But again, work with them through the FEA, through the engineering, through the prototyping, through the PPAP run, and provide the turnkey solution. If we can use a buzzword, a turnkey solution with the team. So not only do we have design engineers, manufacturing engineers, and process engineers, and we can assist a customer with their hydroforming, tooling, and that's we do. Even if it was something that we didn't make at Schuler, we can assist with that.
Right. Were you familiar with hydroforming when you got involved in manufacturing in general?
I wasn't, and that was part of the excitement for me, as I mentioned, having a metal stamping, wire forms, tube bending, CNC bending, some machine tooling. Back in the day, hydroforming, I understood what it was, and I had the misconception that a lot of people do, it's really expensive, and it's these little tiny small parts for plumbing and really exotic. So I'm learning in almost a year now with Schuler, really learning about hydroforming and what can be done and what can't be done, because not every you can't. I mean, you can draw it in CAD, but you may not be able to hydroform it, or the tooling investment may not justify the need. So
yeah, what's been some of your big highlights since you've started working with the hydroforming?
Just highlights for me is learning and being able to help the customers develop. And we had a success story with another Detroit 3, able to make another advantage of hydroforming a success story. And obviously EVs and electric vehicles are all the buzz these days. But a customer came to us, and they have an electric version of the vehicle and a gas version of the vehicle. And the part was their upper radiator support, very similar, except a little kick out in it. And through hydroforming, we're able to make typical hydroform die, at least a Schuler die, has 2 cavities. Like I said, it's much like a mold. Right. We're able to make ICE version, internal combustion engine version, and a battery electric BEV version in the same tool with each press stroke.
Oh, wow.
So that's another advantage to hydroforming. And you got 2 cavities, and as long as your parts are reasonably close, or they're not larger than the press bed, you can make multiple parts in the same press stroke.
Oh, wow.
So you're not constrained. The other advantage to hydroforming, and what's not a success story, but what I think is neat, is we're concerned with outside of metal. So that rollover protection system I mentioned, where we were able to incorporate 5 to 7 parts into one,
Right.
we're able to make, we're down to 2, but we made 4 different products, wall thicknesses in the same die. So we currently make a 4 millimeter thick part and a 6 millimeter thick part in the same die.
Wow.
So different than stampings, where you'd have to change everything and shim everything up. So we're able to offer multiple products as well as cost reductions. Sometimes a customer will come to us and say, we want to reduce material and take cost out, take weight out, and we're able to do that with hydroforming with little, sometimes no, but if little adjustment to the tool. It's typically the seal cone if you're changing the diameter, the inside diameter. So that's a real, what I think is neat about hydroforming versus stamping and other metal fabrication processes.
Yeah, it's amazing the consistency you get out of the process.
Yes,
Part to part.
Part to part plus minus 0.5 mil, 0.1 mil,
Wow.
1 mil. So yeah, very, very consistent. Another success we've had at Schuler is working with dual phase material. So your Gen 3 dual phase material, you get a lot of spring back.
Right.
And we've worked with customers where, I won't say who, but they've recut a tool a dozen or more times. So our competency and our engineering staff, we're able to, if we quote a customer, 2 recuts with the dual phase material, because we all know dual phase material, it's finicky at times.
Yeah.
But we're very competent in working with that. And you're seeing a lot of dual phase materials in your, certainly automobiles, a lot in your EV. I mean, it's all about, can we keep steel and metal in EV? So we're seeing a lot of dual phase material in the roof rail, the A pillar, the B pillar of the vehicle. So
has hydroforming emerged as a good process to deal with these difficult materials?
We believe so. Absolutely. Absolutely.
It's interesting.
Yeah.
Because obviously with the evolution of automotive vehicles, I mean, there's a lot more new material and a lot more stress being put on those engineers to have fewer parts, lightweighted.
Yes.
And to have this kind of emerge as a tool to help with that is kind of interesting.
It is. And lightweighting is a part of it. I mean, something that hydroforming has been used for many years is in frame components. So we make several frame components where, if you remember back in the 80s and 90s, you had, your body on frame vehicles, they'd rust away because you had 2 C channels welded together, and it was garbage, the frame. But with hydroforming, we take a galvanized tubular hydroform it, laser cut it, and they could put 2 or 3 of those together, and you've got a much more robust frame, less weight, stronger. The other part of hydroforming, it work hardens. So we're basically destruct testing every part.
Right.
So we're work hardening it. In the hitch example, we press bend it, and we add a shape. So we take a round tube, we bend it into a trailer hitch, and we're adding a square shape in the middle. So that gives the customer area to weld the hitch on and weld it to the vehicle, but also strengthens the tube. So we can bring that material up, in a sense, to a higher KSI level, so they get a stronger tube with thinner using. They can, again, every application's different, but can use a thinner material, maybe a less strong material, and bring that up to specification.
Right.
So that helps with the light weighting. With EVs, a lot of the talk is protecting the battery, protecting the occupant, and hydroforming, we're able to add some shape and some to that and give that some strength. We've done in the past a lot of crush tips for body on frame, so to give it strength but also crushability for the impact zone. So that's another thing hydroforming can do versus other processes.
Yeah, and it's fair to say hydroforming has applicability outside the automotive industry as well, I'd imagine.
Absolutely. I mean, years ago, Schuler, we did millions of oven handles and refrigerator side by side handles. But as technology has evolved, I mean, roll forming and plastics have taken a lot of that up. So we used to do a lot in exhaust. We did a lot of fancy exhaust. We've done motorcycle frames, bike frames since the beginning of time, a lot of hydroforming, but other processes have evolved, and we've evolved hydroforming over that time as well.
Yeah, it's kind of fun seeing something that's been around kind of being applied to new applications.
Yeah, I mean, Schuler's almost 200-year-old company, so hydroforming isn't the only thing we do, but a lot of it, has been around hydroforming and having that expertise and seeing seeing the industry to evolve. And it's neat to be here at FabTech and see the other processes and technologies. I saw a booth, they were making oven handles with roll forming. I don't like to see that. I like if they were hydroformed, but they're roll formed, and that's fine too. We'll just make more trailer hitches.
There you go.
And roof rails.
And in summary, water always wins.
Yes.
I like that. So where can they go to find out more information on hydroforming and Schuler?
Schulergroup.com.
Awesome. Thank you for joining us on this episode of the Fabricator Podcast, sponsored by Schuler. Thank you, Chris, for your time.
Thanks, Dan.
Yeah, it was very interesting.
Appreciate it.
Yeah, I enjoyed the conversation. If you have any comments, questions for us, suggestions, send it to podcast@fmamfg.org. Thanks a lot, and remember to tell your friends about the Fabricator Podcast. Bye.
The Fabricator Podcast is a production of Fabricators and Manufacturers Association, located in Elgin, Illinois. The show is hosted by Dan Davis and the staff of FMA Communications. The podcast is produced by Gareth Slager and recorded and edited with the help of Brandon Geyer. Sales support provided by Andy Flando. Additional production support by Elizabeth Gavin, Dana Weicker, Mary Diamond, Mike Owens, and me, Sarah Spring. Thank you for listening.